In this video, we are going to be looking at piecewise functions. And you'll see those in a second. Piecewise functions basically are functions that behave differently depending on your value of x. But before we look at a piecewise function, I just wanted to look at these two little basic functions independently. These are pretty easy functions that I'm sure you've seen something like this before. This first one, you may even be able to graph on your own without a little table, but I'll just go ahead and plug in some values for x and then figure out what our f of x is, or our y value. Negative 2 squared is 4, negative 1 squared is 1, 0 squared is 0, 1 squared is 1, 2 squared is 4. I can go ahead and plot those points. And I get a little parabola that looks something like this. Sorry, my pen's a little wiggly here. And I could plug any value I want to for x. If I wanted to, I could calculate f of 100. That would be 100 squared, number with a lot of zeros on it. I could calculate f of negative 12 squared, 144. I could put in any value I want to for x. Same thing over here on the right. I have this little linear equation. And just do a quick little graph of that. If I plug in 0 for x, y is 10. If I plug in 4 for x, y is 6. Or if I plug in 8 for x, y is 2. So 0, 10. Sorry, I was trying to count my little hash marks. 0, 10 would be right about there. 4, 6, 1, 2, 3. About right there. And 8, 2 would be about here, so we get a little straight line. Missed the points, you get the idea. Again, we could plug any value we want to in here for x and calculate what f of x was. Now in a piecewise function, we can't always just plug in any value for x. You'll notice that up here, this is what a piecewise function might look like. We actually have two different functions put together, and our x value determines which one of these functions we are going to use. So when I graph these, since there are two lines in this piecewise function, I'm going to make two t-tables. This one is for my x squared part. And then let's see if we can get another color. This one will be for my 10 minus x part. Okay, and very important thing to notice right here, we can only use values for x that meet the condition given. Okay, so for the x squared part, that is only if x is less than 2. So we could put in negative 2, we could put in negative 1, 0, 1, and actually, even though x has to be less than 2, I am going to plug 2 in there. I'm going to put a little star about that because we're going to talk about that when we graph it. We don't want to include that endpoint, but we need to go right up to that point, so we need to know what that value is. Okay, and then over here, for my x minus 10, this is only for values of x greater than or equal to 2. So I could plug in 2 or 3 or 4, and I could keep going on and on if I wanted to. 10 minus 2 is 8, 10 minus 3 is 7, 10 minus 4 is 6. So when we go to graph these, what we're going to see is, I'm going to draw a little reference line in here. Sorry, trying to get my pen color. At x equals 2, right here, x equals 2, this is where we see things changing over. If any values to the left of this line, we need to use the x squared function. Any values to the right of this line, we have to use the 10 minus x. So we can go ahead and plot these points that we found. Negative 2, 4, negative 1, 1, 0, 0, 1, 1, and 2, 4. Now be careful there. I want to plot that as an open circle because I want my graph to go right up to that point but not include it because of that less than symbol. Okay, so there's what part of my piecewise function looks like. That's the green part, the first line. The other part is for the values of x greater than or equal to 2. So 2, 8 would be about here. And now I do want to close that circle in because this is greater than or equal to 2 for this part. 3, 7, and 4, 6. So here we get that piece of our linear graph. Notice these did not cross that red line. I'm actually going to erase that red line now because we don't want to keep that in there. It's not an asymptote. That was just helping us notice where the change was happening. So forgive the wiggly lines, but this is what our piecewise graph would look like. Notice it is part of each one of these individual graphs that we started with. Okay, let's look at another one. This is a piecewise graph that has 3 different sections. Okay, so first let's kind of look at our restrictions on x here. We're going to use this first line if x is less than 1. And we'll just draw that in here real quick. That would be anything to the left of this red line. We are going to use this middle function if x is between 1 and positive 4. So that would be this middle little chunk right here in between my 2 red lines. And then finally we use this very last line if x is greater than 4, and that's the piece over here to the right. Okay, so again, I like to make 2 t-tables. For the first part, for x plus 4, that's going to be my first t-table. Okay, here values less than 1, so maybe -3, 0, and I am going to put 1 down there, but remember we don't want to include that in our graph. We just go right up to it. This is a straight line, so I don't really need 3 points, but I just put an extra one in there. So -3, 1, 0, 4, and 1, 5. Remember that one's going to be our open circle. But to the left, this linear graph is just going to keep going and going because any x value less than 1 would fall under this function. Now for the middle section here between the 2 red lines, that's where I'm going to use f of x equals 2, the middle function. And I don't really need to make a t-table. If x was 1, y would be 2. If x was 2, y would be 2. Anything between 1 and 4, y is going to be 2. So we start here at 1, and we're going to include that value because of the greater than or equal to, and we go all the way to 4, which is going to be the open circle, and that gives us a horizontal line for that part of the graph. And then for our final section, f of x equals x minus 5. That gives us another little t-table. And again, in this one, I have to follow this restriction, only values greater than or equal to 4. So maybe I'll try 4, 6, and 8. 4 minus 5 is -1. 6 minus 5 is 1. 8 minus 5 is 3. 4, -1 would be right here. 6, 1, and 8, 3. That gives me a part of a linear graph, keeps going to the right, but stops at this endpoint because we only use this piece of the function for values of x that are greater than or equal to 4. So again, I'm going to go in and erase those red lines. Those were just to help us sort out how to graph it. You do not have to put those on your graph, and you don't actually want to include them in your final graph because we don't want to get confused and think that those are asymptotes or part of the graph. This is what our final piecewise graph would look like. And let's do one more. Okay, again, make sure you look at those restrictions for x. I'm going to do this one without drawing the red lines this time, see how we do. So for our first piece of the function, I just take that first line, x squared plus 2, and what values am I allowed to plug in for x? Well, x has got to be less than or equal to 0. So I could do 0, -1, -2, could keep going as many points as I need here. 0 plus 2 is 2. 1, because it'll be -1 squared, 1 plus 2 is 3. -2 squared is 4. 4 plus 2 is 6. And negative 3 squared is 9. 9 plus 3 would give us 11. So let's plot those points 0, 2. And that is a closed circle because it's less than or equal to negative 1, 3, negative 2, 6. And that other one would be up here off my graph, so I'm just going to leave that. Would keep going to the left, but stops at the point x equals 0 on the right. It's supposed to be a parabola. Sorry, my drawing skills aren't very good with my little pad that I have here. Okay, for the second part of my piecewise function, we can tell by looking, this part's going to be linear. It's going to be a straight line. Here I can plug in values between 0 and 4. I do want to use those endpoints 0 and 4, again, because they're not included, but my graph needs to go right up to that point. So when I plug in 0, I get y is negative 3. When I plug in 4, y is 1. So 0, negative 3, open circle, and 4, 1, open circle, and I connect those two with a nice straight line. That's the next part of my graph. And then this final section, again, another t-table. This time I can use values of x that are greater than or equal to 4. So again, this is a linear one, so I don't need too many points, maybe 4 and 7. Negative 4 plus 10 is 6. Negative 7 plus 10 is 3. So 4, 6. About here, closed circle. And 7, 3, about here. Straight line that continues to the right, but stops at that value x equals 4 to the left. And that's it. That's the graph of our piecewise function.